Sorry, it's just setting up now. Okay, should be good to go. So, so going back to this, right? When we have x squared equals 9, and we need to square root both sides, we get, on a calculator, if you did the square root of 9, you would get x equals 3. That's true. You get x equals 3. But that's not the only thing. Does anyone know the second answer? There should be two answers here. Not just 3. Anyone have any ideas? -3. Right? Let's think. 3 times 3 is 9, but -3 times -3 is also 9. Because your calculator cannot show negative values and positive values at the same time, it only shows you the positive one. So the big thing here about square roots is that when you square root now, right, and we have this, you have to remember now that there's actually a plus minus technically in front of that square root. And what that plus minus means that there's both answers, there's going to be two answers, one that's going to be positive and one that's going to be negative, right? Before, in previous years in grade 9, grade 10, we didn't worry about the negative answers. We only worried about the positives. But now that we're diving deeper into quadratic equations, and we know that for quadratics, unless it's a single, like a single root, where the vertex is the root, in those cases, it's a little bit different, right? Where there is only one root, but in here, right, when you square root a number, you're going to have to consider both roots, where it's the plus and the minus version. So the answer is going to be both +3 and -3. Huh? So then, of course, we also went over the idea of solving by factoring, right? We talked about this yesterday, where you move everything to one side, and then you solve by factoring, and you find your solutions to the equation, right? So just a review of yesterday here. We have 5 on the right. We want to move everything to one side. Everything's already on the left. Everything else is already on the left. So we're going to move the 5 to the left, and that's going to give us x squared plus 7x minus 25 minus 5. Simplifying that will give us x squared plus 7x minus 30. Okay. So we get x squared plus 7x minus 30. Okay. From here, we can factor it, right? If we do our side work here, we can say a is 1, b is 7, c is negative 30, right?
So I have a
AC is
question.
negative 30. Yes.
Why is it 30 and not 20? Because aren't they like minusing it? 25.
Right, but this is already negative. So when you
Oh.
subtract from a negative, they technically add together to make a bigger negative number. Right? So negative 25 minus 5 is negative 30. So once we have that, we write down, all the important parts that we need for factoring, which is A, B, C, and AC. And then two numbers that multiply to negative 30 but add to positive 7.
10 and 3.
Which one's negative?
3.
3 is negative, yes. So 10 and negative 3 would be the answer here for the two numbers. So 10 times negative 3 is negative 30. And then 10 plus negative 3 is positive 7. So that allows us to break our quadratic equation into its factored form. So we get x plus 10 and x minus 3 equals 0. And then yesterday, I had some students ask, how did you, I forget how to solve this again, Remember, it's just taking each bracket and setting it equal to 0. So the first bracket, number 1, would be x plus 10 is equal to 0. And for number 2, it would be x minus 3 is equal to 0. So you set both of them equal to 0, and then you solve for it, which gives you x equals negative 10. And then we get x equals 3 on the second one here. So this is how you solve by factoring. You first factor it, find the brackets, and then you set each bracket equal to 0, and you can solve for the answer. Okay. And you notice we're almost at the bottom of the sheet, so it's just kind of going over more examples of solving by factoring. So I'm going to do the first one. Okay, I'm going to do the first one. You guys will do the second, and then we'll do the third one together. So the first one here, x squared minus 5x plus 6. Same idea. We're going to solve for the factors here. So a is 1, b is negative 5, c is 6, and ac would also give us 6. So two numbers that multiply to 6 but add to negative 5. The gap is pretty big here. So, and since it's a negative and that multiplies to a positive, both numbers should be negative. So it's going to be negative 3 and negative 2. Okay. So just to show you my reasoning there and how I got those numbers, they multiply to a positive number, but they add to a negative, which means they both have to be negative for it to work. Okay. So that's the reasoning why I said they're both negative. So that gives me negative 3 and negative 2. And then I can set each bracket equal to 0. So number 1, x minus 3 equals 0. And number 2, x minus 2 equals 0. And then we solve that out. We get x equals 3 and x equals 2 as our two answers. Okay. So that was for A. What I'd like you to do is now B. So for B, you can choose. You'll notice A is not 1. So choose your method of factoring, whether it's product sum, whether it's the Australian method, or whether it's the fraction, Mr. Choi's method. You can pick whichever method you prefer. Try solving it. I'll give you around 3 minutes, and then we're going to take it out. should be finishing off your factoring now. Okay. Just give you a little bit more time. So we have 2m squared equals 3 minus 5m. I would personally move everything to the left where the m squared is, right? We want m squared to be positive, right? Or the coefficient to be positive. We like having it positive. So when I move everything over to the left, I'm going to get plus 5m and then minus 3 equals 0, right? And doing kind of like the side work here again. So a is 2, b is 5, c is negative 3, and ac would give us negative 6, right? So it's up to you guys how you want to do this, okay? Which method would you like me to do? Product sum, Australian, or so 1, 2, or 3. Product sum, Australian, or fractions. You guys really love the Australian method, eh? Okay, so the people who have posted in chat are 2s. Anyone else have any objections to that? All right, looks like there's no objections from the rest of the class. So we have 2m squared plus 5m minus 3 equals 0. The Australian method basically takes your a value. So we have our two brackets with 2m, right? So just kind of showing the class here how to set it up. So everything divides by 2m, right? And then we have the a value also at the bottom. So all three a values are down. Then we think of the two numbers that multiply to negative 6 but add to 5. And those two numbers would be, anyone? 6 and negative 1. Right? So 2m plus 6, 2m minus 1. The reason why we do it this way is so that once you get here, you common factor from the bracket where you can. So we can common factor the front, which is 2m plus 6. We common factor a 2. We're left with m plus 3, 2m minus 1, all divided by 2. That nicely cancels out the 2 at the top and the bottom, which leaves us with our factor, which is m plus 3 and 2m minus 1. I'm just going to make some extra space. I'm going to delete that. So I'm going to make some extra space here. So once we have that, we can set our two brackets equal to 0. We have m plus 3 equals 0, which gives us m is equal to negative 3. And the second one is 2m minus 1 equals 0, which gives us 2m equals 1, which gives us m equals 1 over 2. Okay? So that's going to give us our factors for using the Australian method and then solving for what the actual variable is by setting each bracket equal to 0. Of course, you don't have to just do one. You can choose whichever method you prefer. If you want me to do the other methods, just let me know. I'd be happy to do them for you. Okay, so whether it's the product sum or Mr. Choi's method, just let me know. You're like, I don't like the Australian method. You can ask for me extra help after class, and we can go over the other methods as well. The last question here was different. It says for part C, determine whether the given number is a root of the quadratic equation. So if we're finding if it's a root, it's very simple. All you have to do is do left side, right side check. Okay, so if you guys remember the left side, right side check, right? We look at the original equation, On the left side of the equal sign, we have 42. On the right side of the equal sign, we have x squared minus x. We then plug in x equals 7 into where x would be in the equation. So the left side, we don't do anything more. On the right side, we are going to plug things in, and we're going to say, oh, x is 7. And so that's going to be 7 squared minus 7. We then solve it on the right side. 7 squared is 49. 49 minus 7, which gives us 42. So does left side equal right side? Yes. Left side equals right side. Therefore, x equals 7 is a root. If left side does not equal right side, then it is not a root. So as long as left side equals right side, we're good to go, and we can kind of continue solving that. Okay? All right. So let's go over some of the kind of practice questions, like the homework questions. So you see there's some homework questions at the bottom there. Let's go over some of these homework questions, okay, to make sure that, well, we are trying some together, because I think some people would like me to do some homework questions during class as well. So I didn't print these out. These are part of your homework listed at the bottom. So we are just going to cover a couple of these. Sorry, excuse me. And then we're going to get started. Okay. So we're going to be covering question 8 specifically here. Maybe 6C. We might try 6C. Okay. So actually, we should try 6C. Let's do 6C as well. It's a little bit unique. It's a little bit unique. So let's do question 8 first. So question 8 looks like this. Okay. So it says a model airplane is shot into the air. Its path is approximated by this function, h of t is equal to negative 5t squared plus 25t, where h of t is the height in meters and t is the time in seconds. When will the airplane hit the ground? Okay, so if the question asks, when will the airplane hit the ground, what are we solving for? If it says hit the ground, could you say that again?
Time?
Time, yes. What information is it giving us here, though? If we were to think of like which point on a graph are we solving for?
0.
0 for which one?
X-intercept.
Yes, height. Yes, height of t. This is saying height is 0, which is the x-intercept. Okay. So when it's asking us when will that plane hit the ground, yes, you are solving for time, right? We don't know what time is. Hit the ground is telling us that the height is 0, which is in turn telling us the x-intercept, which is just another way of telling you, hey, solve by factoring, right? Can you please solve by factoring? So here, so h of t is equal to negative 5t squared plus 25t. So we want to factor this. How do we factor this? What's the number one step? No matter what.
Common factors.
Yes, finding a common factor. So first we look at the numbers. Negative 5 and 25. We can factor out negative 5, that's for sure. Can we factor out a t?
Yes.
Yes, we can. Since there's no c value, if there was like a plus 10 here, then you can't factor out t because everything has to have it. But since there's no c value, we can actually factor out a t here, which makes our life a lot easier. So we're going to factor out negative 5t, and that gives us t minus 5 as our factor. And that turns out that's really nice. This is it, right? So when we solve this, remember how I said set each bracket equal to 0. Technically, this section is also a bracket. So these are the two sections that we have here, right? Even what's multiplying in front can be considered a bracket. So that plus the bracket itself. And that's going to give us two answers. Number one, negative 5t is equal to 0, which gives us, well, the only option is t equals 0, right? If it's just this. Number two, we have t minus 5 is equal to 0, and so that's going to give us t equals 5. So we get two answers where t is 0 and t is 5. From here, what do we do now? Well, we have to answer the question, when will the plane hit the ground? Which answer is correct? 0 or 5? Which one would it be? Is it t equals 0 or t equals 5? Sorry, I heard something. I have friends saying 5 in chat. Anyone else agree or disagree with 5? No one has an opinion this morning? Everyone a little too tired? It's not 0, right? Time equals 0 is when it's thrown. This is when it starts, right? So it can't be t equals 0 because that's when it's being thrown. It has to be t equals 5. So once we identify what the correct answer would be fitting the context of the word problem, we can write our therefore statement. The plane will hit the ground after 5 seconds. Okay. So this would be question 8 within your, one of your homework questions was question 8. This is the answer to that here. Okay. So just kind of going over it. And we are going to do one more together, one more homework problem together. I'm going to leave that so people can copy it down for a little bit, and then we'll move on to the next question. Then we're going to do question 6C. So this is question 6C from your homework. And it asks you to solve by factoring. I would like you to try this question yourself. There's multiple ways you can solve this. And by multiple, I mean 2. There's 2 ways you can solve it. You can expand and factor, or there's another way that you can do it, and I'll show you the second way as well. But I'd like you to give it a shot by yourself first. Can you solve for x? And then we'll take it up. Okay, so I'm going to give you 5 minutes to solve this. Okay? I'm going to give you a full 5 minutes, and then we're going to take it up. Most of you should be finishing off now, right? So I'm going to go through the first method of how to solve it, and then I'll show you the second method of how to solve it. So the first method is what most people, I think, did, which is to expand the brackets and move everything to one side. So here, x plus 5 squared, if you expand that, I'm just going to kind of quickly expand this here just to save some time and space. You should end up with, okay, x squared plus 10x plus 25. If you followed the perfect square trinomial expansion, that's fine, that works out. You should end up here. Minus 6 is equal to x plus 5. Moving everything over to the left, gives us this, right? Minus x minus 5, and we saw that minus 6 there. We then collect like terms, and we're going to be left with x squared plus 9x, right, plus 14. Okay, which gives us a is equal to 1, b is equal to 9, c is equal to 14, and ac is equal to 14. Two numbers that multiply to 14 but add to 9 is going to be 2 and 7. Whoopsies. Which gives us x plus 2 and x plus 7 as our two answers here. Our two factored forms, our brackets. We then set each bracket equal to 0. So x plus 2 equals 0 gives us x equals negative 2. And x plus 7 equals 0 gives us x equals negative 7. So there's our second option here. Now, some of you don't like expanding. You're like, oh, expanding is such a pain. It puts so many errors, so many possible errors, right? So there is another way you can solve it that will essentially remove a lot of the factoring for you. Oh, sorry, not a factor, expanding for you. I'm going to go over that here. But I'm going to leave this on just for a couple more seconds for people to copy down. And then we're going to resolve this using a different method. All right. The second method here, some people might be like, Mr. Choi, I'm never going to remember the second method, but it's good to keep in mind. So here, instead of expanding, you'll notice we have this section is squared, this section is an exponent of 1, and this is your constant. That is technically a quadratic equation. All I have to say is let a be x plus 5. Let a be x plus 5. Okay, so I'm going to write my let statement here. And what that means is I'm going to replace all my x plus 5s with the letter a. So what that turns out to become is a squared minus 6 is equal to a, which allows us to move things over. And it right away gives us a squared minus a minus 6 equals 0. So all I've done so far is I've replaced all my x plus 5s with a, because that's what I'm setting a to be. Okay. In doing so, I can factor this quadratic equation here. A is 1, b is negative 1, c is negative 6. And the two numbers that can do this would be negative 3 and 2. So my two brackets would be a minus 3 and a plus 2. So Notice how the first step is the weird one where we kind of change x plus 5 into a, but it follows the factoring method here. Now this is where people are going to have questions and they're like, Mr. Choi, a is not x. We're supposed to solve for x. You can't tell us to solve for x when we're and then use a. That doesn't make sense. So we're finishing off here, and I'll show you why it does make sense. So then we're going to get a minus 3 is equal to 0, which is a equals 3. And over here, the second one would be a plus 2 equals 0, and that's going to give us a equals negative 2. Once we have that down, we are then going to replace our a's and back into x plus 5. So this is now going to become x plus 5 is equal to 3, 3. And on the second one, it'll be x plus 5 is equal to negative 2. Then you finish solving it, and you should get your two answers. X equals negative 2 and x equals negative 7. And those are the same two answers we got before. So this is another way of solving this question. If you identify, oh, I can see a square. Oh, I can see that that's to the exponent of 1. That's technically quadratic. And you can replace it with another letter and then replace it back at the end after you factor. Just another way of doing it. Do you have to know this way? No. I just thought it'd be really nice for you guys to kind of see different ways of solving it. And some people might be like, oh, that is a little bit easier. So it's always nice to kind of cover it. If you like the regular way of just expanding and factoring, you can definitely do that. That's no problem. Okay. All right. So these are two homework questions that you are going to do, or you would have done for 3.4. So you can try these again yourself, and then we can take it up. Okay. All right. So moving on here, we are then going to move on to 3.5, which is this page here. This was supposed to be a group worksheet, but group work online, a little bit more difficult, right? I can throw you into breakout rooms, but I don't think you guys will be comfortable in doing so, except maybe a couple of you if you guys are already friends. Like a couple groups might have friends, but if I do it randomly, y'all going to be like, I'm not going to talk, I'm not going to help anyone, so we're just going to do this together. So recall, right, our methods. We are trying to solve for roots, our x-intercepts, and of course, finding the roots, the x-intercepts, allows us to find the vertex as well, right? That x-vertex equation, which was x-intercept 1 plus x-intercept 2 divided by 2, right? So we have a bunch of different ways to do this, right? We have table of values, we got factoring, and we got graphing, okay? If you use technology to graph it, like Desmos, right? Or if you have a graphing calculator and you know how to use it, you can use that as well, right? But Desmos is pretty good. If you use Desmos, just say use Desmos and then include the sketch and tell me the roots, right? So we have our table of values here. We have our factoring here. We have our graphing here. You're supposed to do these, okay? And then you're supposed to hand it in. So this is actually going to be like my homework check at the end of this class, right? Or by the end of this class. So I'm gonna leave this here. Okay, I'd like you to try it on your own. And if you guys want to work together as a group, you can do so. If you want to work together as a group later during class time and just be like, Mr. Choi, could you make a breakout room for us? I'll be happy to do so. Okay. So just keep in mind, this is what you're going to be doing before you leave for class. Once your class has finished this, you can hand it in and you're free to go. Okay. But before we do this, we are going to do one final thing. We need to learn one final thing. Bear with me here. This is not a worksheet that I have already uploaded. This is not part of technically your curriculum, but it's something that you should know. And grade 10 academic students have already learned this before, and it's called the quadratic formula. Does anyone remember the quadratic formula? You don't have to type it out in chat because it's a kind of a pain to type it out. But if you know it, right? It's a long formula. I don't expect you to memorize it. If you memorize it, that's great, right? And the reason why the quadratic formula exists is so that you can solve any quadratic equation regardless of if it's factorable or not. So we've went through situations where number one, you have a quadratic equation or you have a parabola, and we've seen situations where there can be no factors, right? You can't solve this, not solvable, right? Right? There's no roots here. It doesn't hit the x-intercepts. However, you will also be given quadratic equations where it's just not factorable. Because factors that we work with are either fractions, right? They're fractions, or they're just not whole numbers, right? The answers to your factors have to be whole numbers or fractions. They can't be something called rational numbers and irrational numbers. Irrational numbers are numbers like pi, numbers that go infinitely. We can't represent pi with a fraction. It just doesn't work. 3.14 is just an oversimplified rounding value for pi. The pi number itself is infinitely long. It goes on forever and it never stops. So there's going to be numbers in math that, well, you can't really factor a quadratic like that, right? So we're going to be going over some of these, right? Where you can't really factor it. Example here. So let's go through a simple example like this. Uh-oh. My thing is lagging again. Please. Yep, okay, hold on. I gotta replug in my thing. Okay. So let's say you have this equation here. Y is equal to x squared plus x minus 1. If you try to factor this, you would say, oh, this is not factorable. And then you'd say, therefore, no solution. And I'd be like, wrong. I'd be like, this is wrong. Bad, bad, bad. No, not that everything's wrong here. It is definitely not factorable. But that doesn't mean that there's no solution. All that not factorable tells you is that there's no whole number or fractions that you can factor this into, right? So just because it's not factorable doesn't mean there's no solution. So we're going to be using the quadratic formula here, okay? So the quadratic formula, okay? And I'm going to put it in a Word box and type it out because my writing might mess it up and make it a little too confusing. Or maybe I'll just find a, give me 1 second. Let's just be technologically advanced here and be smart about how we do these things. This is the quadratic formula. Okay? Looks complicated, but it's not that bad. The only bad part about this is that making sure that you don't make any mistakes in your calculations. That's the bad part. So here, we're still using ax squared plus bx plus c like we've already done here. And you're plugging it into the formula. So you're still identifying here. What is a? Oh, a is 1. What is b? B is 1. What is c? C is -1. So you're still writing these down, right? Keeping them in mind. But the only thing you're doing with this now is plugging it into the formula. Okay? So what does that give us? Well, that gives us x is equal to, and we're using the formula, negative bracket 1, because that's b, plus or minus the square root of b squared, 1 squared, minus 4 times a, which is 1, times c, which is -1, all divided by 2 times 1, which is a. So notice how I plugged it in here. Okay. I've just taken my a, b, c values and plugged it into where they are in the quadratic formula. Okay. So once we have this here, we can then solve it. Do it step by step. Okay. So I'm not just going to solve this all at once on my calculator. That's a big no-no. I do it step by step. So first, I'm going to do these following sections. This can be done really easily. You just multiply the negative. The bottom math can be done, 2 times 1. And then we're going to do the inside of the square root here, section by section. So here, x is equal to -1 plus or minus the square root. 1 squared is 1. And then I'm going to multiply all of this. So -4 times 1 times -1 gives me +4. All divided by 2. Okay, and I'm going to rewrite that square root. So it should simplify to this, which allows us to continue and write this. Notice how that's not exactly going to be a nice fraction, is it? Or a whole number. So this is what we have here. We're going to take this and we're going to split it into 2 sections. Okay? So we're taking this and we're splitting it into 2 sections. The first section is that the number that comes out of the square root is positive. The second section is when the number from the square root comes out as negative. Just like that. From here, you use your handy dandy calculator and you're going to calculate this. So if I do this, give me 1 second. Let me bring up my phone here on screen so that you can see it. Okay, so there's my phone. So here, what I'm going to be doing is -1. You can do this all at once. So if you do this all at once here on an Android phone, it's very easy, right? You can type it exactly as is. But so you can technically do like -1 plus square root 5 divided by 2. That would get you your answer. But let's take it slow. Just solve the square root first. So I'm just going to first find the root of 5, which gives me 2.236. So for us, we're going to write that down. So that's going to give me 2.236. And then the second one, or we have x is equal to -1 minus 2.236 divided by 2. Now we can solve that out we get 1.236 divided by 2, or we have negative 3.236 divided by 2. Then we solve that out, and I will get x is approximately equal to 0.618, or x is approximately equal to, and then if I do, sorry, I noticed my calculator's not up there. If I do negative 3.236 divided by 2, it equals negative 1.618. And these would be my two answers. Notice how you can't really factor these numbers out, can you? Right? But those are the actual roots of our quadratic equation. Just because it's not factorable doesn't mean there's no roots. So it's something we really want to keep in mind when we solve for these equations. Okay? So the quadratic formula is like your last resort. If it doesn't factor and you can't graph it nicely, quadratic formula would be the one you use. Okay? So I'm going to give you one more question to try using with the quadratic formula. Okay? So give me a sec to find a question for you. Okay, you can definitely do this for even factorable equations. The quadratic formula works for anything. All quadratic formulas, or sorry, all quadratic equations can be solved using the quadratic formula, whether it's factorable or not. The only times this fails is when there actually are no solutions, which is a negative in the square root. Your calculator will not calculate that. It's impossible. You cannot do a negative square root. So that's when you say there's no solution. Okay, so let me just get another example here for you. Okay, so I'd like you to try this one. Let me see if I can select and delete these sections here. I'm going to be giving you, it's very similar to the one we just did. So hopefully that helps. Oh my gosh, my freaking tablet is doing it again. Okay, so we're going to get 2x squared plus 3x minus 1 is equal to 0. So can you please use the quadratic formula on this equation here and try to simplify all the way to the end. I'm going to give you 5 minutes to do so. We're going to take it up, and then the rest of the time till 11, you guys can work on the homework and hand it in on Google Classroom. So I deleted the work from earlier. So if you wanted to see that, you can see it on the YouTube video in a bit. But yeah, I can zoom out just a little bit. Okay, hopefully you guys are around at least halfway. If not, the main thing I want to see is, can you plug it in correctly here? Right? It's very important that you plug it in correctly into the quadratic equation here. Okay? So, okay. So here, once again, we first write out what is A, what is B, what is C, and we're going to plug that into our quadratic formula here. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a, right? So negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And then we simplify the math here. Negative 3 plus or minus the square root of 3 squared, which is 9, minus negative 4 times 2 times negative 1 gives me positive 8, all divided by 4, because 2 times 2 is 4. That gives us x is equal to negative 3 plus or minus the square root of 17, all divided by 4. Nice and easy there. Which gives us our two options. Number 1, negative 3 plus root 17 divided by 4. Or x is equal to negative 3 minus root 17 divided by 4. So on our calculator, we're going to divide by root 17, or we're going to find root 17, sorry. And root 17 gives us 4.123. So on the left, we get negative 3 plus 4.123 divided by 4. On the right, we get negative 3 minus 4.123 divided by 4. Okay. So that's going to give us 1.123 divided by 4 here. And this one here is going to give us negative 7.123 divided by 4 here. Right? And just to show you the math there, if you do it on a calculator, negative 3 plus, whoopsies, negative 3 plus 4.123 gives us 1.123. And on the right, negative 3 minus 4.123 gives us negative 7.123. We can then divide these by 4 to get our final answer. So x is approximately negative 1.78. And on the left here, 1.123 divided by 4 gives us 0.28. And these would be our answers. Okay. So I'm purposely giving you ones, of course, that are like not factorable in the regular way to kind of prove the point that you can use a quadratic formula. But of course, like I said, you could even use these unfactorable ones if you're really lazy, like I don't want to factor. You can use the quadratic formula and you'll get your answer. Okay. Any questions on the quadratic formula? I'm going to zoom out so everyone can see the full thing here. Any questions? Going once? Going twice? All right.